Okay, in this video, I want to look at two graphs side by side, and we're going to do this for several different examples. But in all cases, the red graph is going to be f of x, and the blue graph is going to be f prime of x. So we've got a function, f of x equals x squared, and then we have its derivative, f prime of x, or dy dx, equals 2x. And so the key thing that I want you to see here is that here, the blue, the derivative, this gives the slope of the line. So this function, the y value of the blue line, gives you the slope of the red line. So right here, right there, the blue line has a y value of -2, and what that means is that the red line has a slope of -2. So negative means it's going down, and then 2 means it's going down 2 for every one that it goes over, right in that region. Then right here, the blue line has a y value of 0, which means that the red line has a slope of 0. And where the red line has a slope of 0, it's horizontal. Okay, and then similarly, if I go here, right here, the blue line has a y value of 4, which means that the red line, y equals x squared, has a slope of 4. So right at this point, the parabola y equals x squared has a y value of 4, plus it also has a slope of 4. Right here, if I go click right there, okay, right there, the red line, y equals x squared, it has a y value of 1, and it has a slope of 2. Okay, so whenever the blue line is below the x-axis, that means that the graph is going down. Whenever the blue line is above the x-axis, it means that the red line is going up, has a positive slope. And wherever the blue line crosses the x-axis, it means that the red line, which is f of x, is horizontal, has a slope of 0. Okay, so let's look at another one. We talked about this one, y equals sine x, and its derivative is cosine x. Okay, so you can see if I zoom in on this point, and I zoomed in way farther than I needed to, but basically that's my f of x. So my function is y equals sine x, right up here, and at 0 it's got a slope of 1. So that right in this region, right around 0, the slope of the line is 1. So if I pull out, I'll see that the blue line gives me the slope of that function. And so right there, my blue line is saying that at x equals 0, the slope of y equals sine x is 1. Okay? Then if I look right there, this is telling me, the blue line is telling me that the slope of sine x at this point is 0. So the blue line goes from being positive to negative. So this means the red line has positive slope. This means that the red line has negative slope. Right there, that means that the red line has 0 slope. And if I look up, sure enough, right at that point, y equals sine x has 0 slope. So don't look at the slope of the blue line, look at the value of the blue line. So right here, the y value of the blue line is 0.5. And what that means is that right there, the red line is going up with a slope of 0.5. So it's basically over 2 up 1. So over 2 up 1 gives me a slope of 0.5. The blue line tells me that the slope at that point is 0.5. All right. And then also you'll just notice here, if I zoom right in there, that value is 1.5708. And if you guys know your trigonometry, if you multiply that by 2, 1.5708 times 2, and you get 3.14. So basically what this is showing us is that sine of x has a slope of 0 at pi over 2, which means that it's reaching a maximum at pi over 2. Okay, so it's got a maximum at pi over 2, and a maximum means that the slope is 0. It's got a minimum at negative pi over 2, and I think that's about all I want to say about that one. Okay, let's look at something else here. I want to look at x cubed minus 4x. I like this graph a lot. So take a minute to pause the video and use the power rule to see if you can figure out what I did this one in a previous example, so I've got it. I think I'll just leave it like that because I like this function. Okay, so the derivative of this is going to be 3x squared minus 4. All right, let's zoom out a little bit. And resize, drag it over where we want it. Zoom in just one more. Okay, perfect. Okay, so let's look at regions on the blue graph. In this region here, the blue graph is positive. In this region here, the blue graph is negative. And in this region here, the blue graph is positive again. So that means that in this region, the red graph has a positive slope, which means that it's going up. In this region here, the blue graph has a negative value, which means that the red graph has a negative slope, which means it's going down. And in this region, the blue graph has a positive value, which means that the slope of the red line is positive. Now if we look, go on the blue graph, lock right on the intercept there, where the blue graph changes from being positive to negative, the blue graph is 0. So the derivative is 0, and that means that the slope of the red line is 0. And there we see that right at that point, the red line has a maximum because it goes over, it rolls over, and right at that point, it's got a slope of 0. Down here, the blue graph goes from being negative to positive, so my red graph goes from going down to rolling over, so then it's got a slope of 0, and then it comes back up. Okay, so that's more how you can use the blue graph, how you can use the graph of the derivative to help you know things about the slope of a function. Okay, and so then let's look down here. What's happening at that point right there? Okay, the blue graph there has a minimum value at -4. Well, what's that telling me? Well, what that's telling me is that the steepest that the red graph goes down is with a slope of -4, and its steepest slope is right in this region. So right there, this is the steepest downward slope that y equals x cubed minus 4x has. And everywhere else, it's more positive than that. So right there is my absolute most negative slope on the graph, and its value is -4. Okay, I think that's about what I want to say in this video, and I think next video I'm just going to talk about points of inflection while we're here.